All right, everyone listen up. Today, we're not just talking about theory. We are in the middle of a live, real-world crisis. A critical cloud environment is under attack, and we are going to walk through securing it step by step, right now. Let's get to it. Okay, the alert just came in, and it is bad. I mean, really bad. Our most valuable asset, our proprietary AI model, has been stolen directly from our cloud environment. This is a massive breach, a huge theft of intellectual property, and we need to act immediately. To put this into perspective, we're not just talking about some lost files. The AI model that was just taken is valued at over $10 million. But honestly, the money is just the beginning of the problem. An attacker can now copy our tech, sell it to our competitors, or even worse, reverse engineer it to find new ways to attack our own systems. The damage here could be absolutely devastating. All right, time to get to work. First things first, we need to figure out exactly how the attackers got through our defenses. And to do that, we have to understand the battlefield itself, the cloud. So what even is the cloud, right? Well, forget the jargon for a second. It's basically a global network of incredibly powerful computers that we can use over the internet. For a company like ours, it's the engine that powers everything we do, especially our AI development. Training AI models takes massive data sets and a ton of processing power, which is why our entire operation, servers, models, databases, lives in the cloud. And here's the key idea. Instead of spending millions of dollars buying and maintaining our own physical servers, we just rent what we need from providers like Amazon Web Services or Microsoft Azure. This gives us amazing flexibility to scale up or down whenever we need to. But as we're seeing right now, it introduces a whole new world of security risks.
Now, there are a few different ways to do cloud, and each one changes how much control and responsibility we have. We can rent the raw hardware, servers and storage, like with AWS EC2. That's called infrastructure as a service. Or we could use a pre-built platform, like Azure App Services, where we just have to worry about our code. That's platform as a service. And finally, you have what most people use every day, a finished product, like Gmail. That's software as a service.
And here's the part that is absolutely crucial to understand. The more control we take, the more security responsibility we have. With IaaS, we're in the driver's seat, which means we're on the hook for securing everything from the operating system on up. But with something like SaaS, the provider handles almost all of it. It's always a trade-off between control and convenience. This brings us to the single most important concept in all of cloud security, the shared responsibility model. Think of it like this. The cloud provider is responsible for the security of the cloud, the physical buildings, the hardware, but we, the customer, are responsible for security in the cloud, our data, our applications, and who has access to them. They secure the building, but we have to remember to lock our own apartment door. So, what was the brilliant, sophisticated hack that brought us to our knees? Well, it wasn't one. It was a simple, preventable human error. One of our own engineers accidentally left that digital door wide open. They uploaded our AI model to a public storage bucket, and the attacker found it with a simple Google search. It sounds like a rookie mistake, but it happens all the time. And as you can see, the consequences can be absolutely devastating. Okay, we know how they got in. Now it is time to kick them out and slam the doors shut. We have to assume the attacker is still in our network. Our top priority is containment, cutting off their access completely and regaining control. So the attacker has a password. That's a key to our front door. The question is, how do we make that stolen key completely and utterly worthless to them? That's our challenge, and here's how we solve it. First things first, effective immediately. Weak passwords are dead. From now on, every password will be a digital fortress. That means long, complex, a mix of upper and lowercase numbers and symbols, just like we practiced back in the lab. This is our new baseline, our first wall of defense. But a strong password alone isn't enough anymore. So now we deploy our secret weapon, multi-factor authentication, or MFA. With MFA, even if an attacker steals a password, it's totally useless without that second piece of proof, like a code from your phone. This one simple change is a total game changer for our security. Next up, we are putting every user account on a strict need-to-know diet. This is called the principle of least privilege. The idea is simple. You only get access to the systems and data you absolutely need to do your job. It's like giving everyone a key, but that key only opens the doors they're actually supposed to go through. No more, no less. And here's what this looks like in the real world. We are creating a strict role matrix. Developers, They can deploy applications, but they can't touch our financial databases. Security engineers, they can monitor our systems, but they can't change any code. By walling off each role, we create digital bulkheads that will contain a breach if one ever happens again. Okay, the doors are locked. Now it's time to reinforce the walls and build a fortress. We need to harden our defenses, protect our crown jewels, our data, and make damn sure a breach like this can never ever happen again. From this point forward, all of our sensitive data gets locked in a digital vault. It's called encryption. Think of it like a secret code that scrambles our data, making it completely unreadable to anyone who doesn't have the specific key. It doesn't matter if it's a massive AI training dataset or customer info in a database. It all gets encrypted. And it's not enough to protect data when it's just sitting there. We also have to protect it when it's on the move. That's where data in transit encryption comes in. It's like sending our data through an armored truck. We use secure protocols like HTTPS to create an encrypted tunnel that shields it from anyone trying to eavesdrop. Look, a strong defense isn't a one-and-done fix. It's a 24/7 job. That's why we are implementing continuous monitoring. We're setting up a digital security team that's always on duty, using powerful platforms called CMs to watch our systems, hunt for threats, and respond in an instant. And here's a perfect example of what this system can do. At 10 a.m., a user logs in from Nigeria. No big deal. But then, just 5 minutes later, the same user account logs in from Russia. Now, unless they've mastered teleportation, that is physically impossible. And this is where we turn the tables and use AI as our weapon. Our threat detection system is like a digital bloodhound. It spots that impossible travel anomaly in a split second. And before a human could even finish reading an alert, it has already locked the account and neutralized the threat. It's faster and smarter than any human team could ever hope to be. So we've contained the breach. We've secured the perimeter. The immediate crisis is under control. But let me be clear, this is far from over. Now, the real hunt begins. It's time to find out who did this to us. In our next explainer, we're all going to become digital detectives. We're going to dive into forensics and learn how to follow the digital breadcrumbs these attackers leave behind. We'll cover how to preserve evidence correctly, how to build a case, and how to trace an attacker's steps. We're going on a digital manhunt, and you're coming with us. We've secured our systems. We've protected our company's future. But the person who did this is still out there. And as long as they are, this isn't over. So the real question is, can we find them? Can we actually bring the thief to justice? Join us next time, and we'll find out.